Welcome to the deep dive. Like us, you probably see the output of AI everywhere now. The chatbots, the image generators.
hmm
It just sort of appears on your screen, right? Like magic.
Yeah, it feels very abstract, like it's just floating out there in the cloud.
Exactly. But our mission today for you is really to look behind that screen. We want to dive into what our sources are calling the invisible machine.
Right, this huge planetary scale setup that actually makes all this advanced AI possible. This deep dive is about, well, getting that knowledge quickly, looking at the actual foundation.
Absolutely. And the core idea we're digging into is that all intelligence needs some kind of physical base to run on, a substrate.
We're talking energy grids, silicon chips, massive data flows, investment capital, all interacting in these constant feedback loops.
And understanding this whole hidden ecosystem, well, that's just crucial if we want to steer this technology in a good direction.
It's like you can admire a supersonic jet, right? But you can't actually fly it or, manage air traffic control unless you understand the physics, the fuel it burns, the whole system. We have to get real about AI's physical body.
Okay, let's start right there. The physical substrate, it's so easy to think the cloud is just ethereal, but our sources really hammer home how physical modern AI actually is.
Yeah, surprisingly physical.
It starts with stuff you can measure, like in gigawatts of power and nanometers on a chip, not just software code.
That's the key shift in thinking. Data centers. They're basically the digital foundries for this era. Or maybe the steam engines. They're turning raw electricity into computation.
Wow, steam
Yeah.
engines of the cognitive age.
Pretty much. This new kind of intelligence, it's hungry, it runs on electricity, lots of it, and infrastructure.
I saw some numbers in the research that were just staggering. Like, training one big AI model can use as much energy as a small city over several days.
It's immense. And it's not just electricity, is it? You mentioned something else earlier.
Oh, right. Water. Loads and loads of water for cooling these massive data centers.
That's a huge point, often missed. The cloud isn't floating free. It's physically connected to power grids.
Yeah.
And it needs enormous amounts of water. Think about data centers in places like Arizona or Utah.
Already water-stressed regions. Okay, so that's a very real physical constraint.
Absolutely.
And beyond the resource cost, what about the geopolitical side? Does this dependence mean that every time I ask a chatbot a question, I'm kind of plugging into a global supply chain? Maybe even a conflict?
Well, in a way, yes. That dependence ties AI directly to global systems. It starts with things like mining rare earth minerals,
Yeah.
maybe in the Congo,
Okay.
then moves to highly specialized factories,
Yeah.
semiconductor fabs, maybe in Taiwan.
Which we know is a geopolitical hotspot.
Exactly. So the answer you get on your screen, it's literally the end product of complex global logistics
Yeah.
and, yeah, some pretty tense international relations.
So the argument here is that AI isn't some clean, separate digital thing. It's deeply woven into the planet's resources and politics.
Precisely. It's like how the Industrial Revolution reshaped landscapes to power factories. This AI revolution is doing something similar, just maybe more quietly for now. It's rewiring energy grids, shipping roads.
And if we only look at the cool apps,
We miss the foundation. We risk building something unsustainable because we ignored the real costs.
okay, so physical infrastructure is the body, what's flowing through it. That takes us to the digital substrate. Data as the lifeblood, right? This massive flood of text, images, code.
Right. But what's really interesting here isn't just the sheer amount of data, it's the speed, the flow, and how it feeds back on itself. That's where the acceleration really comes from.
You mean recursive learning? Can you break that down a bit?
Sure. Think of it like this. An AI system tries something, produces an output. That output then gets fed back into the system as new input.
Okay.
So the system learns from its own results, gets a bit better, produces a slightly better output, which again feeds back in. It's a loop.
A self-improvement loop that just keeps speeding up.
Exactly. That's the core of what some people call the law of accelerating returns applied here.
But here's the tricky part, according to the sources. That feedback loop, that acceleration, it's described as fundamentally amoral. Why is that word so important?
That's key. It's crucial because it explains why AI getting smarter doesn't automatically mean it gets better for us. The loop doesn't care about ethics or truth. It just amplifies whatever signals are strongest in the data or whatever goal it's set.
So if you feed it biased data,
It gets really good, really fast at being biased. The bias multiplies exponentially through the loop.
or, okay, I see this online. If the goal is just keep users clicking, maybe the system gets really good at generating, I don't know, outrage. because that works.
Precisely. If engagement is the metric, things like polarization or misinformation might accidentally become the optimized product because they grab attention effectively. The loop doesn't judge, it just optimizes.
So we need to think bigger than just the algorithm.
Yes, it demands systems thinking. You have to look at the whole circuit board. The incentives driving the companies, the quality of the training data, the safety checks, the policies. Otherwise, you might just be building a super fast engine for noise, not wisdom.
Right. The speed is the power, but also the danger. And that engine is already reshaping how business works. Which brings us neatly to part 3, the economic engine. The birth of the inference economy.
Yeah, that's a great way to put it. There's a really profound shift happening kind of under the surface.
Yeah.
We're moving away from an economy that mostly made money by collecting data.
Like old school social media mining our clicks.
Exactly. To an economy that makes money by using that data to make instant predictions and generate insights. That's inference.
So the value isn't just having the data anymore, it's being able to turn it into, like, foresight, predicting what happens next, faster than anyone else.
That's the game now. Who can transform that torrent of information into predictive power the quickest?
How does that look in the real world? What are the examples?
Oh, it's everywhere. Think about retailers predicting what you'll buy next week, maybe even sending you coupons before you've thought of it.
Creepy, but okay.
Or hospitals using AI for diagnostic inference, maybe catching diseases earlier from scans. And of course, governments trying to get strategic inference, predicting geopolitical moves or military actions.
So the real race is for the best models and the sheer computing power to run them, to pull meaning out of the noise faster.
Right. And this is where it gets concentrated.
How so?
Well, building and training these massive models is incredibly expensive and complex. It requires huge amounts of data, specialized chips, and expertise. This naturally leads to concentration.
You mean just a few big players dominate?
Yeah, the sources call them computational superpowers. They benefit from what you could call algorithmic economies of scale. The better they get at building models, the easier it is for them to build the next even better model. Their advantage just compounds.
That sounds like it could lock everyone else out. Smaller companies, researchers, maybe even entire countries can't keep up.
That's the major concern highlighted in the research. Without deliberate efforts to ensure broader access and, fair competition, this could really widen the gap between the AI haves and has-nots.
Turning it into a deep structural divide.
Potentially, yes. A structural divide in access to knowledge and economic power.
Okay, to really get our heads around this whole system, the sources suggest we need a different way of looking at it. This brings us to part 4, complexity, materiality, and this thing called the pacing problem.
Yeah, the suggestion is to stop thinking just about the AI things, like a specific app or chatbot.
And think more about the flows.
Exactly. Flows of energy, flows of data, flows of capital, flows of ideas. See it as a dynamic system.
Because they all affect each other, right? Like dominoes.
Totally interdependent. So if you disrupt one flow, say the U.S. blocks exports of high-end chips to China, you see ripples everywhere. AI research slows down globally. Investment shifts. It's all connected.
It's a complex, adaptive system, as they say. And this connects back to something you mentioned earlier, getting past the mirage of immaterial intelligence.
Right. We love this idea that software is just thought stuff eating the world. But it's not. Intelligence always needs a physical grounding. Every calculation, every digital neuron has that energy footprint, that water footprint we talked about.
And a human footprint, too, which is often hidden.
Absolutely. Critical point.
Yeah.
Often invisible. We're talking about potentially hundreds of thousands of people, often in the global south, labeling data to train these systems.
Or in the grunt work.
Yeah. Or content moderators who protect us from seeing the worst stuff online, often at great personal cost. And the technicians keeping the data centers running 247. This AI revolution is fully embodied, it's networked, and it relies on people.
Acknowledging that hidden reality is vital for fairness.
Definitely.
Okay, and that brings us to the final piece of this section. The speed. The recursive loops we discussed create a fundamental challenge for how we govern this stuff. The pacing problem.
Yes, this is maybe the central governance challenge. The tech iterates so fast. An AI model might go through hundreds of versions, getting significantly more capable in the time it takes a government committee to even draft legislation.
So the tech is moving exponentially, while our laws and regulations move, well, linearly, at best.
Right. There's this widening gap. Technology sprints ahead, and governing struggles to keep pace. We're constantly reacting, always a step behind.
Okay, so if the pacing problem is the core challenge, what's the solution? How do we govern something moving that fast? Part 5, governance at the speed of recursion.
Well, the idea gaining traction is something called anticipatory governance.
Meaning,
It means building foresight and, crucially, flexibility directly into the rules and regulatory systems themselves, not just static laws passed every few years.
so the governance system needs to learn and adapt, almost like the AI does.
Exactly. If the technology evolves in loops, the governance needs its own feedback loops. It needs to become a learning system, too, adjusting much faster than traditional lawmaking allows.
Can you give us some concrete examples? What does that actually look like?
Sure. One idea is regulatory sandboxes. These are like controlled environments where companies can test new AI applications under specific, perhaps relaxed rules, while regulators watch closely, learn, and figure out what permanent rules are needed.
So learn by doing, basically.
Kind of. Another approach is adaptive risk-tiered regulation. The EU's AI Act tries to do this. It sorts AI systems based on their potential risk level.
High risk gets more scrutiny, low risk gets less.
Right. And crucially, those rules and risk levels need to be revisited and updated frequently as the tech changes. The goal is precision intervening where it matters most without stifling innovation across the board.
So the big shift in thinking is moving away from this idea of controlling AI, which seems impossible anyway,
Pretty much, yeah.
towards finding ways to intelligently co-evolve with it, using these more nimble, learning-based governance tools.
That's the aim. Because the power of AI and also its dangers really come from all these interconnections we've been talking about, the physical, the digital, the economic, the social.
Okay, let's try to pull this all together then. This has been a deep dive, really peeling back the layers from the shiny screen to the messy reality underneath.
So to quickly summarize for you, we've seen AI isn't magic. It's a vast networked system.
Yeah.
It depends heavily on physical stuff, energy, water, minerals.
Yeah.
It's driven by these incredibly fast, amoral feedback loops using data.
Which is creating this new inference economy, concentrating power.
Right. And the sheer speed and complexity of it all creates this massive pacing problem for governance.
Meaning we need smarter, faster, more adaptive ways to guide it, like anticipatory governance.
Exactly. It's about seeing the whole system.
Okay, so the final thought, the kind of provocative idea we want to leave you with is this. Maybe the most important question isn't just what can AI do anymore. Maybe it's what kind of system are we actually building around this technology? Because that invisible machine, the energy grids, the data centers, the economic incentives, the rules we set, ultimately, that's us.
It's a mirror. Our energy choices, our data habits, our values, reflected back at us through silicon.
So if you want to shape it wisely, you really have to learn to see the whole system, not just the glowing screen in front of you.